Imagine standing on the edge of a vast red desert, with dusty winds whispering tales from billions of years ago. This is Mars, the red planet, one of the most captivating worlds in our solar system. But beyond its mysterious surface and rusty color lies a story far older than we can truly grasp. Long before humans ever dreamed of rockets or rovers, Mars was already spinning in space. It's not just another planet, it's a prime suspect in our cosmic search for life beyond Earth. But perhaps even more fascinating than the possibility of aliens is what Mars can tell us about time itself. Mars is ancient. Its rocky surface holds secrets of the past, stories written in stone, shaped by volcanic eruptions, mighty winds, and the slow creep of ice. Scientists believe that by understanding the age and formation of Mars, we unlock a deeper understanding of how all rocky planets, including Earth, came to be. But how do we even begin to measure something so vast in time? Through years of study, scientists have developed incredible methods to calculate the age of planets like Mars. By examining Martian meteorites, studying surface craters, and analyzing geological layers, researchers piece together a timeline that stretches back more than 4.5 billion years. And why does this matter? Because every clue about Mars's age is also a clue about our own planet's history, and perhaps even the story of life itself. To truly understand Mars, we have to travel all the way back, not just thousands or millions, but billions of years ago. Picture a swirling, chaotic cloud of dust and gas dancing around a young, fiery sun. In this cosmic nursery, tiny particles began to collide, stick, and grow. It was a slow and violent ballet, guided by gravity and chance. This process is called planetesimal accretion, the birth of planets from dust. Over time, bits of rock and metal clumped together, becoming larger and heavier with every impact. One of these growing worlds would eventually become Mars. Mars was quick to take shape. Unlike Earth, which continued growing and evolving over a longer time, Mars formed fast, and then it stopped. Its growth halted early, leaving it smaller, colder, and more geologically quiet than its blue neighbor. But that early stop? That's what makes Mars so special. It's like a time capsule, preserving conditions from the earliest days of the solar system, untouched by the same level of tectonic chaos and recycling that reshaped Earth. Here's the mind-blowing part. While the solar system was still a wild storm of swirling dust, Mars was already taking shape. Thanks to isotope studies, a kind of cosmic fingerprinting, scientists have discovered something astonishing. Mars may have fully formed just 2 to 4 million years after the Sun was born. In cosmic terms, that's lightning fast. That early formation puts Mars among the first planets to emerge in our solar system. While other planets were still assembling their parts, Mars had already carved out its place, quietly orbiting the newborn Sun. Because of this head start, Mars became a kind of preserved relic, a snapshot from the solar system's childhood. Its early birth means it holds clues to a time period that Earth and other planets have long since erased through volcanic activity, tectonic shifts, and erosion. By studying Mars, we're not just looking at another planet. We're looking at the solar system's memory. Now here's a tricky question. How do you measure the age of a planet? It's not like planets come with birth certificates, and scientists can't exactly slice them open and count the rings like a tree. Instead, they rely on a set of clever scientific detective tools, methods that help them estimate age, not by looking at the planet directly, but by reading the ancient clues it leaves behind. Think of it like piecing together the life story of a long-lost civilization from scattered ruins and buried fossils. For planets, those fossils come in the form of rocks, meteorites, and surface features that tell us how long they've been around. Scientists don't use just one method. They combine several approaches to build a reliable picture. One of the most fascinating ways scientists uncover Mars's age doesn't even require setting foot on the planet. Instead, the answers sometimes come crashing down to Earth. Literally. Over the years, pieces of Mars have broken off, blasted into space by ancient asteroid impacts, and eventually landed here on our own planet as Martian meteorites. These space travelers carry secrets locked inside their rocky cores, just waiting to be decoded. Using a technique called radiometric dating, scientists study how radioactive elements like uranium slowly decay into more stable elements, such as lead. It's like having a natural stopwatch built into the rock. By analyzing how much of the original radioactive element remains, and how much has turned into something else, researchers can calculate how old the rock is, often down to millions of years. And because these meteorites formed when Mars was still young, they offer a rare glimpse into the planet's earliest days. It's like finding an ancient diary from Mars, with each page written in atoms and time. If Mars had a face, it would be covered in scars, ancient craters left behind by countless cosmic collisions. These impact craters aren't just dramatic features on the surface. To scientists, they're time markers. The more craters a region has, the older it likely is. It's a simple but powerful idea. A surface that's been exposed for billions of years has had more time to be pelted by space debris. By counting the number and size of craters in different areas, scientists can piece together a relative timeline of Mars's surface. Some parts are heavily cratered, telling stories from the very beginning of the solar system. Others are smoother and younger, shaped by volcanic flows or shifting sands. But there's more. To fine-tune their estimates, researchers compare Mars's craters to those on the Moon and Earth, where we've already measured the age of certain surfaces. This comparison helps translate crater density into actual age. Each crater is like a wrinkle in Mars's skin, a sign of its long, turbulent past. Of course, not all of Mars's secrets are written in stone. Some are revealed inside supercomputers, through the magic of numerical models, digital time machines that let scientists rewind the clock and simulate how the solar system was born. These models recreate the chaotic early days when dust and debris whirled around the sun in a cosmic blender. By adjusting variables like gravity, collision rates, and orbital motion, researchers can watch virtual planets take shape. And guess what these simulations show? Mars didn't just form early, it formed faster than its rocky neighbors, Earth and Venus. The models suggest that Mars raced through its growth stage, assembling from planetesimals in just a few million years, while the others took much longer to mature. This rapid formation may explain why Mars is smaller and less geologically active today. It simply ran out of building blocks before it could grow bigger. Thanks to these virtual experiments, we're able to glimpse a version of the past no telescope could ever see. A time when the planets were still just children, finding their place in the solar system. After years of studying meteorites, counting craters, and running powerful computer models, scientists have reached a remarkable conclusion. Mars was born between 4.3 and 4.58 billion years ago, just a few million years after the Sun first ignited. That makes Mars one of the oldest planets in our solar system. While other worlds were still assembling their pieces, Mars had already taken its place in orbit, quietly watching the chaos unfold around it. In many ways, Mars is more than just a planet. It's a witness, a survivor from the earliest chapter of our cosmic story. Its ancient rocks, frozen plains, and battered surface carry the memory of a time we can never directly observe. Studying Mars is like reading the first pages of the solar system's autobiography, a story written in stone, silence, and stardust. Knowing how old Mars is isn't just about satisfying curiosity or ticking a box in a science book. It's much deeper than that. It opens doors to big questions across multiple fields of science. Mars's ancient age helps us understand the timeline of planetary formation, how quickly rocky worlds can take shape, and what happens when they do. It also provides clues about the conditions needed for habitability and whether Mars might once have had the right ingredients for life. For geologists, Mars offers a rare look at a planet that didn't go through the same geological recycling as Earth. That means its surface holds some of the oldest unaltered rocks in the solar system, a natural laboratory for studying early planetary crusts. And for astrobiologists, the age of Mars sets the stage. If life ever had a chance to emerge on the red planet, it would have happened very early, during a time when the planet was still warm, wet, and active. In short, Mars isn't just another world. It's a key puzzle piece in understanding how planets form, evolve, and maybe, just maybe, come alive. One of the most incredible things about Mars is not just how old it is, but how little it's changed compared to Earth. While our own planet has been constantly reshaped by tectonic shifts, volcanic eruptions, and erosion, processes that erase ancient history, Mars has remained relatively quiet, and that makes it priceless. Because Mars formed quickly and stopped growing early, it holds on to traces of the primordial processes that built the rocky planets. It's like a time capsule, sealed for billions of years, preserving evidence of a time long lost on Earth. By studying Mars, scientists get a rare glimpse into the raw beginnings of planetary evolution, how dust became stone, how stone became worlds, and how some of those worlds may have once teetered on the edge of life. In a universe full of mysteries, Mars is one of our best clues to understanding not only where we came from, but how planets, and perhaps life, begin. But perhaps the most fascinating question of all is this: could Mars have hosted life before Earth? Because Mars formed so early, and its surface stabilized long before Earth had oceans, it might have had the right conditions for life while our planet was still a molten ball of chaos. If microbial life ever existed on Mars, it could have been the first in the entire solar system. That makes Mars's age more than just a number. It's a cosmic clock, offering the timeline for when life might have begun and where. Even today, scientists continue searching for signs: fossilized bacteria, organic molecules, or tiny traces left behind in ancient rocks and underground ice. Every mission to Mars is, in a way, a search for a lost chapter of the universe's story. Because if life did start on Mars first, it wouldn't just change how we see that red dot in the sky, it would change how we see ourselves. Understanding Mars's deep geological history isn't just about looking back. It's also about looking ahead. Every crater, every rock layer, every patch of frozen soil tells scientists where to search, where to land, and maybe, one day, where to build. Ancient terrains may hold the fossilized evidence of past life, hidden deep in Mars's oldest rocks, relics from a time when the planet may have been warm and wet. Meanwhile, geologically younger regions, shaped by volcanic flows or shifting ice, might offer resources future explorers will need to survive. Underground ice for water, minerals for construction, even clues to natural shelters beneath the surface. In this way, Mars's story becomes a map, a guide for humanity's next giant leap. The more we understand its past, the smarter and safer our journey into its future will be. At an age of approximately 4.5 billion years, Mars is not just one of the oldest planets in our solar system. It is a silent witness to the earliest moments of planetary formation. Its rapid birth, forged in the violent chaos of the young solar system, offers scientists a rare and invaluable opportunity to study how rocky worlds like Earth first came to be. Through the careful analysis of Martian meteorites that have crash-landed on Earth, the examination of countless impact craters etched into its dusty surface, and the sophisticated modeling of planetary evolution using powerful computer simulations, researchers have slowly pieced together the planet's long and complex history. But Mars is more than just a subject of scientific curiosity. Its story carries profound implications, not only for the field of planetary science, but also for astrobiology, as we search for signs of past or present life beyond Earth. And as humanity begins to dream seriously of setting foot on another world, Mars also stands as a symbol of our future, inviting us to explore, to discover, and to expand the boundaries of what is possible. In understanding the ancient history of the Red Planet, we take one step closer to understanding our own place in the universe and what lies ahead in the vastness beyond.